Hello everyone, this is Caplitero and welcome back to a new episode. Today we're gonna talk about 3D vectors. You're gonna ask me, why am I in a Photoshop file? Well, because I need to explain you some stuff. I want to create some basic uh, 3D rendering stuff, but to get there, I'm gonna need to show you guys some basics. Well, uh, I'm gonna start with 3D uh, vectors and cross product. Well, what's cross product? Let's say that we have a 2D plane. We know, so we have x and y. I don't need to write them right now. You have x and y. Well, you can see those are perpendicular. Those are actually also perpendicular on each other, the x and y axis. But we can actually find a third perpendicular. We call it the z function. And we can find vectors that are perpendicular to each other. We always know that x, y, and z are perpendicular. But what if you want to find something that is made of three points, random points in space? Well, we need to find the perpendicular giving those points. So how are we gonna do that? Well, we can know this. Let's say this is the x-axis. We don't. You can always rotate the third axis. Doesn't need to be z, y, or x, or it's whatever you want. But what do we do? We first say uh, right or axis. Whoa. And there's one thing you might find in math, physics, and everywhere. There is not there are those are not always called Z, Y, and Z, X, Y, Z. They're actually called I, J, and K because those are directions. If you want to find something in the direction of I, we multiply it by a scalar, by a length. And if I told you that those lines are perpendicular, if you apply the cross product, what does it suggest? Well, let's say we multiply I, I'm gonna call it like this, times j. Well, their perpendicular is k, isn't it? Um, let's say j times k. Well, their third perpendicular is I. It doesn't need to be always perpendicular. Those can it can be like this, and their intersection will also have a perpendicular. I'm just saying that those three are always perpendicular. And our third axis is that times I, which is equal to j, or j. And there's something very interesting because if we rotate those, let's say we have j times I, it's, it's equal to minus k. We go in the opposite direction. So if we say that j times I is equals minus k. Um, k times j equals minus I. Gonna have minus I. And k times I times k equals minus j. You can see that we have all the axes all on the same point that we call origin. We call it O, big O, with 0, 0, 0, origin. And what's all of this? Well, let's say that we have a vector. We have it right here, A. A will have it's a point in space. It will have a vector x, y, z. We can say that A is equal to first component of A times I. So the scalar times I, the direction. So we have I is just a unit of measure. If we say A1 times y, it will say it will be like here or here. That it all matters on A1 plus the second component times j and the third component times k. And let's say we also have b. B is b1 I plus b2 j plus b3 k. Or if you want, we can call it x. So this is x of a1. This is y of a1. Oh, of a. I'm sorry. So of a, and z of a. But what now? Cross production is basically the same thing as a production. So if you say a times b, we're gonna take everything from inside. So I don't know how to write a1 I plus what did a2 j, I was right, plus a3 k multiplied by b1 I plus b2 j plus b3 k. I hope that you understand. And just like basic production, I'm gonna take the first and the second. What will it return? So let's say a1, we can move it to the back, the I times b1. We can make it a little bit obvious. I times I. Well, what's happening? Why did we get I times I? Because you're multiplying a1 times I times b2 times I. And what do we do right now? Because we don't know anything about it. Well, the thing is that when this happens, it's very obvious. They're both going in the same direction. There's no change and there's nothing. This will return 0. I it's it's not much to explain about this. They are just going in the same direction. There's no change in, let's say, movement, because this is about physics, and their force to this point is 0. They are not pulling apart the point, and it will return 0. And what's next? A1 times B2 J. I times J is K. So we're gonna have, let's move a little bit down, and we're gonna have a1 times b2 I times j, which is equal to I times j, I1 b2 k. But we have next, we're gonna have a1I and b2k. You can see right here minus j. So we're gonna have a1 times b3. I'm gonna put this in front, j. You can see that there are three terms, three components, three components. How many zeros are we gonna have? Three, because I times I, j times j, k times k. We're gonna be left with six components. Um, I'll write them real quick and be back because it takes a lot of time. Okay, I'm back. I had to write a bit, so we went to the steps from before, and we found, as I said, one, two, three, four, five, six, with 2k, 2i, and 2j. We can actually put those in little brackets, I mean parentheses. But you'll see something interesting. A2, B3, this will be I and Z, Z and I. 3 and 1, 1 and 3. Z, X, X, Z. 1 and 2, 2 and 1. A, Z, uh, I, X. So X, I, X. So those are, let's say, the coordinates. It's a vector of I point X. Why did I say 1 right here? I right here. Don't take this in account. So we can say that A times B will have a CI plus CJ plus CK. 1, 2, 3. And this is C1, C2, and C3. It doesn't matter if these lines, I mean, it does matter if they're collinear, but if they are not on the same direction, um, this uh, production will result a C, a vector perpendicular to these two vectors in the point where they meet. X, X and Y, they meet in the origin, and you can see that Z is perpendicular on the origin. They can be on the plane. It can Z can be anywhere on the plane. It doesn't matter. But it's easier to understand if you fix it in this point of intersection. You can move Z along the plane, so you can say we could have it right here above the eye. This will also be Z, but it's easier to understand if you look on their intersection. That's why there's an X right here. Well, hopefully everything right here was everything you needed for product, course product. I'm sorry if I'm writing awful. Um, I'm not writing with a pen or anything. I'm using my mouse. You know this. But at least I'm not painting in paint anymore. But this is all I need to present you guys. There will be a video with more of this. And what can I say? Thank you for watching and see you next time, guys.